Now let us check the correctness of another equation. This is our equation. Fs is equal to half m v square minus half m u square. This is one of the equations. Fs means force into S displacement. Force into displacement is equal to work done. What is half mv square? Half mv square, it is the equation for kinetic energy, and v square means, v means final velocity and u is initial velocity. So what is half mv square minus half m u square? This is final kinetic energy and this is initial kinetic energy. So this is change in kinetic energy. So work done is equal to change in kinetic energy. And let us check the correctness of this equation. And it is based on which principle? It is based on homogeneity principle. If this equation is dimensionally correct, then dimension of S will be equal to dimension of mv square is equal to dimension of mu square. Let us check the correctness of this equation. So let us take the first term, Fs, which is equal to, what is F? F is force and S is displacement. What is the dimension of force? Force equation is F is equal to ma. M is mass, its dimension is capital M. Then A is acceleration, its dimension is Lt raised to minus 2 into S is displacement, dimension L. So dimension of Fs is equal to m L square T raised to minus 2. Then let us consider the second term. What is the second term? We don't want to consider this half, and dimension of mv square is equal to, dimension of mass is capital M. Then it is not v, it is v square. So what is the dimension of v square? Dimension of v is Lt raised to minus 1. So we have to square it because it is v square. So it will become ml square. ml square t raised to minus 1 square means t raised to minus 2. So see here, they are having the same dimension. So let us take the last term. What is the last term? mu square. It's again dimension is of m is m and u is velocity, that is our initial velocity. Its dimension is Lt raised to minus 1 the whole square. It's again m L square T raised to minus 2. So all the terms involved in the equation are having the same dimension. Dimension is ml square T raised to minus 2 for all the three terms. So we can say that this equation is dimensionally correct according to the homogeneity principle. Now let us take another example. Let us consider this relation. Tau is equal to I alpha, and we are going to check the consistency of this equation. Here this equation has only two terms. One is tau and other is I alpha. And here tau is known to you. What is tau? Tau is torque. But the other two terms are not familiar to you. The other term I is called moment of inertia. Moment of inertia. You will learn about this moment of inertia in one of the chapters, but now this is an unfamiliar term to you, and I will tell you how we find this moment of inertia. Moment of inertia, I is equal to mass into distance square. This is the equation for moment of inertia. And the third term is alpha. Alpha is called angular acceleration. Angular acceleration. Angular acceleration means when an object moves in a circular path. It's moving, so it has acceleration. And here we can find an angle when it moves in a circular path. You can there is an angle subtended here, and angular acceleration is equal to angle divided by time square will give you angular acceleration. So these are the three terms. One is torque, second one is I, moment of inertia. Its equation is mass into distance square, and alpha is angular acceleration. It is equal to angle by time square. So let us check the consistency of this equation now. Tau. What is tau? Tau is equal to torque. What is the equation for torque? Do you remember the equation? Torque is equal to force into perpendicular distance. Force into perpendicular distance. So the dimension of tau is equal to force, dimension is m, l t raised to minus 2 into distance is l. So its dimension is m l square t raised to minus 2. We have already derived this before. So dimension of torque is m l square t raised to minus 2. Then second term is I alpha. I alpha. I is, let us find the dimension of I and alpha separately, then let us multiply. Dimension of I, that is dimension of moment of inertia. What is the equation? Equation is mass into distance square. Mass into distance square. Dimension of mass is m, distance square. Distance dimension is l, and since it is distance square, it is m l square. So this is only dimension of I. Again there is one more term, alpha. What is dimension of what is the equation for alpha? Dimension of equation for alpha is angle divided by time square. And angle, it has no dimension, so no dimension, and dimension of time is t square, so it can be written as t raised to minus 2 is the dimension of angular acceleration. Now we can find the dimension of I alpha. What is dimension of I alpha? It is I, dimension is m l square, dimension of alpha is t raised to minus 2. So see, dimension of torque is m l square t raised to minus 2, and dimension of I alpha is also m l square t raised to minus 2. So we can say that this equation tau is equal to I alpha is dimensionally correct.